Alright, the purpose of this video is when we're thinking about a scatter plot, you guys, so if we're thinking about x and y now, so we call it bivariate data because there's two variables that are changing, and we have a scatter plot of dots, and then you have one dot that's kind of separated from the others. The purpose of this video is for us to think about what counts as an outlier on a scatter plot, what counts as an influential point on a scatter plot, and then what would happen if we removed that point from the scatter plot. So again, the main things that you want to make sure that you understand by the end of this video is what makes something an outlier, what makes something influential, and what would happen if you removed it, and how should you think about that when you're working through a problem. So first let me show you this graph right here. If you can see it, it has a bunch of dots clustered down here in the bottom left corner of the graph. And it has this one dot way up here in the top right corner. And I have sketched in red what I'm going to call the line of best fit, or the linear regression line. Well, to figure out if something's an outlier, you have to figure out if it has a large residual. What does that mean? The large residual means, is it far away from the line of the best fit? So right here, is the dot far away from the red line? No, it's on the red line. So we would say that this is not an outlier because it is right on the line. An outlier would be something that is far away from the line. Far away from the line. Second, is it influential? So to make something influential, it means that it has a big effect on the line. In other words, if it were not there, the line would look a lot different. And just as a hint, when you have something that is far away from, when you have a dot that's far away from all the other points on the x-axis, it makes it way more influential. And so this dot, our prediction is that it's definitely influential, and I think that we would be able to confirm that. Since I don't have specific numbers on here, we can't use our calculator to prove it, but this is going to count as an influential point because it is so far away on the x-axis from all the others. So it's not an outlier because it's right on the line, but it is influential because it's far away from all the others on the x-axis. And if I removed it and I looked at all the other dots, the line wouldn't look the same. The line would look a lot different. Let's look at a different graph. So in this graph we have a moderately strong negative correlation with this one dot far away from the others. Is this an outlier? Is it far away from the line? Well, yes. If we look at it, it is very far away from the line. It has a large residual. Is it influential? We're predicting that yes, it's had a big effect on the line, because if it weren't there, the line of best fit would probably go right through the center. So this last part of the video, we're going to talk about what would happen if you removed a dot. So first, what would happen to the correlation? Would it increase or would it decrease? For now, we can say that we can't tell unless we had the numbers, but it looks like it might increase because the dots are all together, or maybe you'd say decrease. That's a matter of opinion. So on this first problem, it's not clear, but on this one, it is clear. If you take away this point, the correlation is going to get much stronger. The dots are all together in a downward slanting line, and we can kind of sketch in what that line would probably look like. I'll do that in blue right here. So without dot A, we might estimate that the new line of best fit would be right here in blue. What do we know about this line? Did the slope increase or decrease? Well, the line got steeper. So technically, the line has a bigger slope. I mean, it's more negative, but the absolute value is a bigger number. So it's a steeper line. What about the y-intercept? Well, the y-intercept, it looks like, went up from red to blue. So the y-intercept increased without that outlier. And we would know that the correlation got stronger. The correlation technically increased. The correlation got stronger. So these are some ways that you need to think about what would happen if you removed an outlier. Looking last at this one, if we remove this point, you might estimate that the new line of best fit would be barely increasing, if not just no correlation at all. So it changes it a lot. You can see that the y-intercept, it looks like, increased a lot. The slope decreased though, and it's hard for us to tell about the correlation. Okay, take some time to finish your notes for this section. Thanks for watching.